The robot design is mainly the EV3 with the wheels and the steel ball. Attached to this, we have the color sensor and the ultrasonic sensor. One of our biggest concerns was to develop a robot whose hardware could really help him to fit into the ecological niche. This way, we will avoid computation or text that can be performed simply by its mechanical structure. Therefore, the bearing is composed by an internal ring attached to the robot through these 4 points. We also have this other external ring that can freely rotate around the robot, thanks to these 50 bearings. All these parts have been printed with a 3D printer using PLA, polylactic acid. When the robot reaches any body, it orientates completely perpendicular to it. The external ring touches the body through a single point, and thanks to the big friction, it does not slide. The bearings between both rings allow the robot to rotate among the object and so orientate itself towards it.
The robot strategy is based on reinforcement learning, a way to gather information from the environment without previous knowledge. The principle of learning is based on experience and the interaction with the environment. The learning is made by trial and error. It resembles much more the natural way we learn. For our experimental setup, the reward function will look schematically like this. We use Gaussians because they are easily tweaked by changing only a couple of parameters. And by simply modifying their width, you can lead to very different scenarios. In the exploration mode, the robot wanders around the playground and gathers information from the different objects that it encounters. Thanks to its mechanical structure, it faces the objects automatically. This allows us to use only the proximity sensor, and once an object is found, activate the color sensor. If the color it detects is anything but white, it will keep surrounding the object. If it is white, it is assumed to be a wall, so it turns back 180 degrees and adds some randomness in the final angle, so it is not always performing the same action. Once we learn enough about the ecosystem through exploration, we stop the robot and perform offline learning. The offline learning basically comes down to treat all the data from the positions that it has been at every time and the rewards that it has obtained on these positions. On the exploitation mode, our robot selects the best trajectory in order to maximize its benefit. That's called a greedy strategy. As you can see in the video, it goes straight to the preferred choice of food and then goes back, always trying to avoid those locations that in the past gave him a negative reward.